Hello everyone. Modern technology is designed to simplify and make our lives easier. And in this video I will assemble a simple acoustic switch that will turn on and off the load when you clap or even when you click your fingers. This is a very useful and interesting DIY. As usual, I will assemble the device using volumetric mounting. The frame of this device consists of two rectangles, a large and a small one. I bent the rectangles out of copper wire, the diameter of which is 0.5 millimeters. The schematic diagram of this device can be downloaded in the Telegram group. Also in this group you can ask a question that interests you, offer ideas for a video or just leave your opinion on a topic. The link to the group will be in the description below this video. Join us. The scheme of this device is quite simple. The basis of this scheme is a bistable multivibrator assembled on VT1 and VT2 transistors. This multivibrator has two stable states. First state, transistor VT1 is open and VT2 is closed. No voltage is supplied to the load. When popping, the multivibrator switches to the second state. That is, a negative voltage drop from the microphone closes the transistor VT1 and opens the transistor VT2, which, in turn, opens the transistor VT3 and voltage is applied to the load. At the next clap, a positive voltage drop from the microphone switches the multivibrator to the first state, that is, to standby mode. The power part of the circuit that controls the load is assembled on the VT3 transistor. If you plan to use a more powerful load than the LED, then the transistor, respectively, should be more powerful. For example, tip 30. If there is a relay in the load instead of LEDs, the circuit will look like this. The supply voltage of this circuit is from 3 to 9 volts. In this homemade I use an electret microphone CZN15. Of course, it can be replaced with another similar microphone. A microphone and inlet will be placed in a small rectangle. There is a beginning, and at this stage everything turns out well. In this device I use transistors BC547 and BC557. This is a complementary pair. If necessary, they can be replaced with other transistors suitable for the parameters. For example, S9014 and S9015. The more gain the transistor has, the more sensitive the acoustic switch will be, and the more clearly it will be triggered by a clap or a click of fingers. More than half of the scheme has been assembled. It remains to solder 5 resistors and a capacitor. It turned out to be such a compact device. Now I will solder the wires to supply the supply voltage, and check how this acoustic switch works. Now let's check at what maximum distance this acoustic switch will work. Well, as the experiment showed, At a distance of 2.5 meters, this acoustic switch works clearly and reliably. If the distance is more than 2.5 meters, then sometimes the device does not work, that is, this acoustic switch does not respond to every clap. It is also worth considering that the microphone was not located directly in front of me, but, as it were, on the side. If the microphone is right in front of me, the distance at which this switch will be triggered will increase to 3-4 meters. Well, with this arrangement, 2.5 meters. For such a simple scheme, this is also very good. As the test showed, such an acoustic switch works quite clearly and reliably. And this concludes this video. If you liked it, then click on the subscribe button under this video. Also click on the bell icon next to this button, and then you will definitely receive notifications about the publication of new videos on my channel. I thank you for watching and bye.